Hey, y'all. How's it going? No. This is the first session at Build. We haven't been together in a while. Howdy, y'all. Thank you. That's better. I'm Brady Gaster, and today we're going to talk about .NET and Cloud Native development. I'm super excited to be back in person. Super excited to be online as well. I do have a lot of teammates here today. Really quickly, teammates, raise your hands. Cool. The reason I bring this up is I'm going to try to get to some questions at the end, but there are some people downstairs in a very big room waiting for me. So I'm going to have to run. So if I can't get to your questions, it's not that I don't want to. We have a lot of other folks in the room who can help out with those questions, but I'll try to get to them as best I can. So let me go ahead and address the elephant in the room. Your book says .NET 8 Cloud Native, right? Right? Okay, that's not what we're going to talk about today. We're going to talk about .NET Cloud Native because there's a lot of stuff that we've done in .NET prior to .NET 8 that is cloud native that enables a lot of stuff for you. I'm going to show you some of that stuff today, and we're going to talk about some of the new waves that are coming out in the future. But before we do, one of the things that I want to bring up is this idea that we have a virtuous cycle of constantly improving both our service owners' experiences for using .NET and .NET, because those service owners are outspoken. They like to tell us their requirements. They like to tell us their dependencies. And what happens is they build these huge services, which we'll talk about too in a moment, using .NET, and they come to us and they say, here are our requirements, here are our dependencies, here's the RPS we need to maintain, yada, yada, yada. Can you make it work? And there are times when we haven't already made it work. So we work closely with those teams to make sure that .NET can support their services that run in the cloud. And their services are big. Let's talk about two of them. Bing ads. So think about all of the ads that you would see on Bing, any search. Think about all the advertisements that Microsoft Advertising supports, from mobile ad campaigns to various website campaigns. It's a lot of ads. It's a lot of traffic too. 5,000 to 7,000 RPS at all times. So they came to us and they said, we really, really like this, and we really, really like .NET. We've already got 7 million lines of it. We've got 600 some odd projects, 500 NuGet package references, but we really, really enjoy .NET. We want to enjoy .NET in some of the new and exciting ways. We want to be able to deploy on Kubernetes. We want to be able to deploy to Linux. So we want to move to .NET 6 at that point in time. Team, I'm going to say .NET Core today. I'm sorry. Okay. .NET 6. They went to .NET 6. So the point in time where they went to .NET 6, they were also able to move to Kubernetes. Guess what else they did? Dramatic reductions. Dramatic reductions in their compute costs. Dramatic reductions in their WCF memory usage. Does anybody want to take a guess what other dramatically got reduced? Spend. They spend less money. If you do less compute and you use less memory, you're going to spend less money. So we were actually able to save Bing ads money by moving. And they've got a blog post that wrote a bunch of details about that. If that's not cloudy enough for you, let's think about our cloud. Let's think about app service. Anybody have any idea how many HTTP requests are served by Azure's app service paths? Well, I have an idea. 160 billion plus a day. Pretty significant. What else is significant is when they came to us and they said, we have this need, we want to update to your reverse proxy. Sam Spencer's in the room, he should be hooting right now. YARP, our new reverse proxy, they came to us and they said, we wanted to basically enable this ability, we wanted to bring this proxy to app service. Think about that for a second. Think of the challenge. You've got a PaaS that has lots of app sites running on it, serving lots of traffic. You have to change out your reverse proxy. One of the PMs said that it felt like changing the tires on an F1 car while it was in the middle of a race. Because you can't break the car and you can't break the traffic. You can't break the folks getting the traffic. So, where are they? Well, just like Bing Ads, they were able to significantly reduce their per CPU cost. They were able to save on compute, which is valuable for them because they kind of are one of the compute layers. So if your web app runs in app service, it's going to be beneficial for them to save on compute because that means more horsepower. It means less spend for them. But we were also able to unlock some SNI features as well as some SSL features. But that's not the important part. How many of you filed an issue on either the ASP.NET Core repository or the app service repository asking for gRPC on app service? How many of you filed an issue? How many of you complained about it? Well, we unlocked it with that. So this was a great example of when we were able to increase performance, but we were also able to increase the quality of the customer experience by giving customers new scenarios that they previously did not have before. This was super exciting for us. We were also able to get that issue off our plates, so that was exciting. So one of the things I've talked about in here is deploying, .NET framework on Windows with Bing ads, and then they wanted to go to Kubernetes, and then app service who had a reverse proxy. There's a lot of things in cloud native, and as we've talked to customers, this question comes up all the time. How many of you have asked this question yourselves? How many of you have gotten into very heated debates with your teammates over this question? Okay, all of us in the team have, believe me. So we talked about this a lot. What does it mean to be cloud native? So we really thought about it, and we came to the conclusion there's a really great organization out there that's a part of the Linux Foundation called the CNCF, the Cloud Native Computing Foundation. And they basically take care of, provide guidance to, and shepherd really important projects that are cloud native projects. Things you might have heard about, Kubernetes, Helm, things you'll hear about today, Prometheus, Jaeger, those sorts of projects. At various levels of graduation and various levels of maturity, the Linux Foundation supports these open source projects. As such, they wrote a pretty good definition. I'm not going to read the whole thing. And I didn't use this phrase when I was rehearsing, but I sent one of the teammates a text today, and I said, I think we've inadvertently created a bingo game out of the CNCF definition. But that's kind of a good thing. So let's go ahead and start our game. Here's the first part. We've already talked about .NET Framework running on Windows. You're going to see .NET running on my machine today. You can run .NET pretty much anywhere you can run Linux. So if you can imagine public, private, and hybrid cloud support baked right in. We have a lot of customers who buy deploy. They bifurcate their deployment on multiple clouds so that they have the ability to protect themselves in the case of disaster. Let's put it that way, disaster recovery. Go on to the next piece. I think we've proven this pretty good. Have we proven that .NET and YARP enabled the app service team to do a pretty high impact change with minimal toil? I mean, of course there's no big upgrade like that. Sorry, my Dell computer's going, do you want to update now? No. If you think about any big move like that, there's going to be some toil, but they were able to change their proxy while everything was, while the race was being raced. So that's pretty exciting. But this is kind of where we are today. So this is kind of where we are with .NET today. Now, we have a demo project. I have had multiple issues pulling and pushing containers. So I'm going to give you the opportunity to express your disappointment because I have recorded demos today. Aww. Okay. Go ahead. It's cool. Okay. So I'm going to do that because in the interest of time, I just want to get all the pieces in. And I kept having places where things were, I couldn't get this part in. Didn't have enough time to mention this. So I figured I would record it and talk through it. So we're going to do that today for demos. But you'll have a repository that you can party on, and it looks like this. The Contoso Online repository is something that we kind of started. We looked at our eShop, the eShop on Containers app, and we thought we'd love to show that. There's a lot of updates we want to make to it, and there's a lot of updates that a lot of folks have been making to it. But we wanted to start with something a little bit simpler for the purpose of this presentation. Now, for those of you who've seen eShop on Containers, I have good news. For the stuff that you're going to see me talk about today, we are actually in the process of updating that code base with a lot of the newer stuff. So if you've used the sample or if you used the ebook and you've thought, this could use some updates, we're doing that right now. So I do want to point that out. All right, let's talk about our demo app. So the demo app has a couple of different components. The first component is going to be that YARP proxy, and it's going to be some stuff on the back end. I'm essentially going to route everything at root to a Blazor server front end, and then I'm going to route everything that goes to API orders to a back-end orders. Those two will be exposed to the public internet. Obviously, I've got the Blazor server app in front, and then in the middle, I've got this microservice It's essentially an order processor, and we'll talk about what it does when we look at the code here in a second. So let me go forward one more time, and let me see if I can say it right. Can I go to my demo? Oh, thank you. That's cool. It's a first for me. All right, let me hit play. My apologies. I will walk through it. So here's the project in Visual Studio. I'm going to make the repo public probably during the session today. There's the store. Here's the proxy. Now, the proxy really just doesn't have a lot of code. It's just got configuration and route to orders and the front door. So you see the orders right there. And then the final project is this products project, which is a gRPC project. And the idea behind it is it basically takes care of inventory, and the order processor will pull from the orders API and go, do you have any for me to process? If it does, it goes, do I have all the inventory for all the different things in the order? Oh, I do. Okay, ship the order and deplete the inventory. Now, think about that workflow. How many of you have written code for some sort of workflow like that or something a lot harder than that? Probably all of you. The last piece is this diagnostics project, which we'll talk about when we get into observability. It is the only actual project being referenced by the other 4, or 5, or however many, because that's where we're going to light up the diagnostics capability. So I like to use VS Code when I'm doing Docker Compose things, and also when I'm working with Kubernetes, because there's great tools for both. So I flipped over to VS Code, and I've got the Docker Compose file for this app opened up. We could also do this in YAML. I just really wanted to stick to my machine and just kind of talk about .NET more than I talk about different cloud services. I wanted to show you all the .NET stuff and then some of the other cloud native components we could run in containers. So I've got this pulling up. Here we go. So over in VS Code, I've got all the different containers that are running. And if you know about this, it's a great tool. I can actually right-click on each one of these, and I can say open in browser. And it will direct me to the port that is redirecting back into the system. And then this is our Contoso Online kind of front end. Pretty simple. I've used the Mud Blazor library for it. Pretty cool library if you're doing any front end stuff with Blazor. And then this is the orders API. We don't have any orders because we just spun everything up. So I'm going to go ahead and add some stuff to cart and submit the order, flip back over to that orders API. You can see there we've got some orders now. That order will be there for 10 to 15 seconds because the order processor wakes up every 15 seconds, and it will begin to do its work. And we'll look at Zipkin later on to kind of show what that order process looks like. But for now, you can just see as it spins kind of in the background, this is what the logs look like when I go over to VS Code and just do a view logs on that order processor project. If I could go back to my slides, please. Thank you. So that's kind of where we are to get started with the project. I just wanted to make sure everybody kind of had a good feel for that. Now, let me go on and show you what we've done. We filled out a couple of things here. So the first one, containers. There's one word on here that I kind of made a joke with Brendan about yesterday, Brendan Burns. I said, hey, we've both got a slide in our presentation with the CNCF definition. And I was noticing something. There's no security on the slide. And Brendan was like, it's implied. Okay, it's implied. Security's implied if you're cloud native. Okay, so just remember that. You got to do security. But what we decided to do was to implement something that's actually in the Kubernetes pod security guideline. And that is basically non-root support for containers. We've added that in .NET 8, so now your containers will run more securely. So that's something to point out. Microservices. You saw all the different processes. You saw the order processor that will do things. You could argue, and my boss probably will argue with me later, that topology that I showed you could be considered a bit of a modular monolith. Also fantastic for cloud native topologies. But it's one of those things we've seen customers do as they move towards microservices. They'll tend to go to the monolith and then go to the microservice. But you'll see we also have immutable infrastructure support. I could go into that Docker, that running Docker instance, shut down one as long as I've coded for it. We'll get to that later. When I bring it back up, everything will continue to work. So as long as your code is resilient, immutable infrastructures can be supported by .NET running inside of containers. We'll talk about resiliency later on. There I go. Oh, and then the next part is all the new stuff. I didn't see the bubble pop in. So this is where we'll begin to talk about all the exciting new things that we're doing around .NET 8. In .NET 7, we started adding support for open telemetry. So you have a lot of capability around being able to observe your code and how your code is running. That's the idea behind observability. But let's go a little bit deeper into that, kind of explore the 3 really important tenets of observability and talk about the .NET APIs associated with them. Sorry. There we go. So logs. How many of you have ever injected iLogger? Okay, you know what logs are, right? Logs, exceptions, a list of commentary that your code is going to emit. Metrics. The idea behind metrics is that it's quantitative measures, things like CPU, things like memory usage, things like how long it takes to respond to an HTTP request, things like how long it takes to respond to a gRPC request. All of these things are very low-level meters. Some of them are counters that you can turn on, but the idea behind metrics is, or the API behind metrics in .NET can be meters. Now, distributed trace, this is pretty exciting. You'll see it later on in one of the demos. The idea behind distributed trace is I want to execute a command that may run across a series of machines. Like you'll see today, it'll run across 3 or 4 machines, but when you're getting into large microservice topologies, it could be hundreds. So the idea behind a distributed trace is you send a request to orders, orders might send a request somewhere else. You want to be able to track that entire process. You want to track how it spans from one machine to another. That's kind of the idea behind distributed trace, is being able to see these spans of execution from machine to machine and between machines. How do you do that in .NET? Well, in .NET, we have adopted OpenTelemetry, as well as a lot of other vendors, because OTLP is a vendor-neutral protocol for OpenTelemetry, and you can imagine everything on the board supports OTLP. Azure supports OTLP and Azure Monitor, et cetera, et cetera. Now, this is kind of the point where I look up at the board and I start thinking Prometheus, Grafana, Jaeger, blah, 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 all these things. There's kind of like one of my rules about cloud native is for it to be cloud native, it probably ought to work well with something else that's cloud native that you may or may not have already seen. Okay, so OTLP sort of satisfies that for you because it gives you this protocol that all these things can talk to each other. The way that works in .NET is we have middleware that will open up an endpoint that Prometheus will reach out to and begin to scrape. It'll begin to pull data out of your app. Now, if you've ever written a Power BI dashboard, think about the Power BI equivalent in this cloud-native world being Grafana, or some of the Azure tools as well. The idea behind the Grafana is that that is your dashboarding tool, and it has a data source. That data source is Prometheus. So if you're thinking about the Power BI metaphor, Grafana is to Prometheus what Power BI is to your RDBMS. Think about it like that. Now, the distributed trace part, what will happen is all those traces will be pumped out to one of the products that you see down below, such as Jaeger or Zipkin. I'll be using Zipkin. It was just easy for me to grab. I'll be using that one, but the two kind of do the same thing. They draw out the spans of your application. And then there's a ton of different APM tools that you could integrate with this as well, because again, OpenTelemetry, it's OpenTelemetry. If I could go back to my demo, please. Thank you. So this is our quick little demo. It's actually the longest demo of observability with OpenTelemetry in .NET. So I'll move my mouse. So what you'll see is this project is the only project that all these other projects reference. And I have this add observability extension method that I've created, or that Fowler created. He also created this map observability method right here. That one's easier to understand. Map observability is essentially going to create an endpoint for Prometheus to scrape. I believe the default is /metrics, but you can use the options to customize it if you want to customize that URL. If you customize that URL, you're also going to have to customize Prometheus to tell it where to look. But I'll show you that in a second. Now, the code up above, we're going to talk about 2 different pieces. But first, I want to show you the Prometheus stuff. So this is Prometheus inside of my Docker Compose file, and you'll see that I've got this Prometheus YAML. Now, what happens is when the Docker Compose up happens, or if this was in K8s, when you deploy to Kubernetes, these files basically tell Prometheus, this is where you look for data. So these are the URLs that you're going to scrape. You're going to scrape orders, you're going to scrape store, et cetera, et cetera. So that's how I basically wire up Prometheus. And now I can go into my VS Code window, right-click on Prometheus, and hit Open in Browser. That will pop open right here. Now, I'm going to zoom in just a little bit and go to Status, and you'll see here targets. That's what you saw in that Prometheus YAML file. There's all the different things, proxy, the store, and all the different gRPC endpoints. This is all I had to do. I basically had to look at the Prometheus documentation, learn how to write that YAML file, wire this up. Now, you've got managed Prometheus in Azure as well as Grafana. These just kind of run in containers now because we're just going to run on my machine. Now for metrics, this is when I'm actually turning on metrics, and I'm specifically looking at .NET Runtime, ASP.NET Core, and HTTP Client. I want to track outbound requests. I've added a couple of event sources here. Yes, David, I added 2 more from the other day, I'm sorry. And then this is a custom histogram view that I've set up so that I want to basically control how the chart draws according to what I think is good, bad request duration. So what I can like customize that. Now, James Newton King did a great job of working up a dashboard that we'll show you here in a second. And you'll see this is my, just like before, the YAML for my Prometheus. This is the same thing for my Grafana. And if I open up this data, this dashboards folder, I don't know why I waited so long. I really don't know why I waited so long. This JSON file is essentially a Grafana dashboard that has been exported to JSON format. It will kind of get you started with some of the things we think every ASP.NET developer is going to want to have in their dashboard. So I've gone ahead and turned that on, and I've already actually logged into it using the credentials that you'll see in there. This just opens up, and if I click on my ASP.NET Core dashboard, boom, now we can actually see in real time how all the different traffic is happening in the back end. Now, it was set up to refresh every like 5 seconds, and I think the default was to look at the last 5 minutes, but I haven't generated any traffic because I've just been up here talking. So what I'm going to do is flip over to the store one more time and then add a couple of orders to the cart. Submit that order, add a few more to the cart, and whereas before the only thing you saw on the orders was the get, because it was the back-end process making requests to it, now when we flip over, you'll see posts to the products API, to the gRPC, and when I flip to orders, now we'll see posts to the orders over here. So you can actually see all that traffic happening. So that's part of what you get for just enlisting in OpenTelemetry the APIs that we gave you in 7 and in 8. And basically, once you turn on all that OpenTelemetry goodness and you use some of these other cloud-native things, they just light up for you. Zipkin, last piece. I'm going to add tracing to this application. And again, I'm going to trace ASP.NET Core stuff, HTTP client, and I'm going to trace gRPC client. Because remember, that order process is reaching out to both. In this last piece, I'm going to pump that data to Zipkin. Whereas with Prometheus, it pulls, it scrapes out of your app, and when you're sending distributed trace to Zipkin, you're pushing it out. I do want to make that slight distinction. Thank you to my buddy teammate in the room, Sam, for clarifying that to me. Now right here, I'll go up and I'll do a quick little search in Zipkin. What I want to do is look at the distributed traces that have been firing from this order processor. I'll just run this query, and you can imagine that since it's been going back and forth between these APIs, when I click show here, boom. Now what I like about this is if you look at the colors, the dark blue is the order processor, the light blue is the orders API, and the green is the products API. So if you think about being able to look across a microservice topology with these distributed traces, again, I didn't have to go into my logs and write a bunch of queries to do this. I just turned it on. If I can go back to my presentation, please. Thank you. All right, moving right along. Okay, I promise, I know this slide gets old. It's a wave. Okay, we've got 2 more to break down here. The next one's going to be resiliency. Okay, resiliency is really just the tip of the iceberg, but if we stick with the metaphor that I chose, it's one of the branches in some of the new stuff that we're going to do. Okay, so what is resiliency? It's pretty much, resiliency is your app's ability to stay alive in harsh environments. It's got less to do with the fact that you might have an API somewhere in the back end that breaks 10% of the time. And in fact, in a minute when you look at these NuGet packages we're going to show you pretty soon, you'll see that we're going to be adding fault injection capabilities. So you could inject faults randomly, encouraged to be doing that during development, so you write your test to prepare. So, but that's the idea. At the end of the day, your customers, they really shouldn't worry about the quality of some of the APIs that don't impact the customer experience. You don't want them to be unable to buy something because some API way, way back in the back that has nothing to do with purchasing just went out for a couple of seconds, and as a result, the pod is rebouncing. So that's the idea behind resiliency. Now let me go ahead and dive into my resiliency demo, but wait. I have to get to where we are. I jumped ahead a little bit. All right, now let me go to my resiliency demo. Thank you. So here you'll see the store again, and the idea is I'm going to submit a couple of orders to cart. So I'll do 1, 2 orders here. Go ahead and add this one. Go ahead and add them again. Now, I don't have any resiliency turned on in my app. I'm making the presumption that since my code is so awesome, and since the network is so awesome, the front end will always be able to see the back end. Unless something like that happens, in which case I probably need to update the code for this front end to not let people hit the button when it can't make a request to the back end. But that's not the point. What's the point? That's the point. This is what your customers will see when your app isn't resilient. They'll see errors. We don't want your customers to see errors, right? They'll lose faith in your app. They'll lose faith in your product. So the idea to work around that is to add resiliency. So what I'm going to do is go into my program CS, and you'll see that I've got Microsoft Extensions HTTP Resilience. Now I'm going to drop in this method, add standard resilience handler. I'm going to put it on both of these. Now if you look closely at that code, you'll see one of these is an HTTP client going out to the orders API, and the other is a gRPC client going out to the products API. But I can use that method on both. It turns resiliency on for both. Now, if I wanted to customize it, I can customize the circuit breaker options, I can customize retry options, pretty much whatever I want. So I have that capability built right in here. I don't have to go write a bunch of code to check, to check, to check, to check. That's one of the things in cloud native is to be resilient, because pods go up and down all the time. So you want to make sure when they're bouncing and you're making calls to them, you should presume they're going to be back in a second or 2 seconds. So I'm going to go ahead and do a Docker compose stop, and I'm sorry, I meant to do down, so I'll do down again. And then I'm going to re-up the thing. And the reason I'm going to re-up it is that I want that front end to basically come back up with that resilience capability. If I really wanted to show you the immutable infrastructure part, I could have just restarted the store, but I messed that up. So I even messed up a recording. So let me hit refresh here, and now what I'll do is I'll go out, I'll add a couple of items to my cart, I'll hit submit, add a couple of items to my cart. Now I'll create a little havoc. Go ahead and shut off the orders API, hit submit. Again, don't pick on my UI skills. I haven't had a chance to talk to David Pine yet. But you'll see what's happening. I'll go ahead and open up the store in the logs. Look at this. It's retrying. I'm waiting 1 second to retry. So that's just automatic, just for me adding that add standard resilience handler method to both of those clients. I go back to my code after I turn on the pod. The next time it retries, order goes through. So that's the idea behind resilience. Go back to my slides, please. Thank you. But resilience, like I said, is just one of the branches. So that's just one of the things that we're going to be giving you in .NET 8. If you wanted to know what's coming in .NET 8 and beyond, this slide is the beginning of it. This is what we're going to be doing across the entire spectrum for Cloud Native in .NET 8. And I've lost count of how many would be on this if we were ready to release them all today. But this is what you can get today. So in the upper left, you'll see resilience. We've given you Microsoft Extensions resilience, and then HTTP-specific areas of resiliency. Compliance, up in the top right. One of my favorite areas is if you've ever done, let's say, anybody ever deployed a GitHub action? Anybody ever looked in your log file and you've seen the word redacted? Wouldn't it be great if you could just do that for like customer data or GUIDs? Well, we're going to give you that. So we're going to give you log redaction in one of these packages. You can just pull it in and like turn on log redaction. And then because we love to make our code observable and to give you better visibility into it, we're also going to continue to extend the different meters and the capabilities that we're giving you around OpenTelemetry. So we're going to have more stuff coming for that too. So you'll definitely have more observability when these packages come out. But again, these are the packages that I understand have been released today. So you can go and start trying this out today if you want to. We will have some more stuff coming down the pipe soon. I would just continue to kind of keep tabs on it. Now, last time we'll look at the definition. We're going to fill it out. I love this because pretty much after this right here, I can't think of anything on here the .NET could have done. Like, we're not a CI/CD, so robust automation is somebody else. Yeah, I think That's pretty much the best we can do, huh? So we covered everything. Now, scalability is not just what I'm getting ready to show you. I like to talk about scalability in the context of distributed caching. Y'all know I'm a big fan of Orleans, a fantastic cloud-native tool that the .NET team has that enables for all kinds of different scale-out possibilities. But there's other components to scaling your application out that are really important. Startup time and size on disk. So think about an application that is 200, 300 megabytes. And you're running a cloud-native shop, and you deploy, let's say, like your app service, you deploy to 1 million machines. It's very important that the applications you put on those machines are small, because you have a lot of people asking you to put applications on those machines. And in a lot of cases, you want to run multiple instances of those applications. You want to run 2 order APIs instead of just 1, just for fault tolerance. At the same time, have you ever pulled an image from a container registry before? It's better when it's small, right? It's a lot better when it's small. It takes more time to pull that image from the registry if it's huge. Now let's couple that with faster startup times. Let's say we could reduce the size on disk, and we can increase the faster startup time. Now that resilience code that you saw me add before, I'm not going to tell you it wouldn't be necessary, because it's necessary. But what I would tell you is that if it takes less time for you to pull an image because it's smaller, and it takes less time for that app to start up because we improve the startup time, your apps will be more resilient in a cloud-native environment because it's going to take less time for those pods to bounce. And pods bounce, face it. So this slide is deliberately slow on purpose to give me time to get back here. But what I want to point out is all these metrics. So this is before native AOT. So this was, the way things are now, yesterday, what have you. You think about the different metrics on screen. Publish size on disk, working set 235, startup 182, and RPS of 668. Why do I have RPS up there? RPS has nothing to do with density, has nothing to do with startup time. But we wanted to make it smaller and faster, but we don't want to make it worse. We want to at least keep the same level of quality. So it's important to us that when some of these numbers go down, other numbers don't. Before I show you the next slide, I do want to reiterate, this is really just a first step. This is really just our first step in native AOT. David and Damien have a lot of steps they want to take with the team in the future to get better and better. I think they have a session this week as well that you could check out, whether you're here or you're online. But just take a look for David Fowler and Damien Edwards' session on native AOT to learn more about how exciting it's going to be once it's even better than this. So we've gone from 88 to 8. We've gone from 235 to 33. We've gone from whatever the other one was, 182 to 27. And let's look at that RPS, 668, 689. We're good. So this is what we've been able to do so far. All right. Oh, I don't want to go backwards. Let's not go backwards. All right, let's go to my demo real quick. Now, what I'll show you real quickly is that I want to thank one of the people answering questions online, Eric and Fowler, for helping me work this in so easy. So I'm going to open up the CS Proj, and I'm going to open up the Docker file. And then I'm going to go down here to my branch tab in VS, and I'm going to change it from main, which is not native AOT-ified, yes, that's a word, to AOT. And you'll see that that's the first change. Publish AOT is true. And then there's a few other changes that we need to make to that Docker file because we have to put stuff on the machine to compile to native AOT. David and Damien know how to say that a lot more intelligently than I do. Go to their session or watch it online. But at the end of the day, what I wanted to do is shift from the main branch over to the native AOT branch. And then what I'll do is I'll go into Docker, and I'll do a Docker compose down. But before I do that, I want to zoom in on this Docker desktop. You can look here, 215 to 230 are the sizes for all of these container images running on my machine. So we're roughly, just over a gigabyte for the whole microservice topology in terms of size on disk, and that's only if I've got one instance of each one. Okay? Something to think about. So I'm going to go ahead and stop everything, and remember I've switched to that native AOT branch. Cue, drum roll in just a second, everyone. We're going to flip to that native AOT branch, do the build again. Then I'm going to flip over to Docker Desktop. Tip, if you want to show something like this, it doesn't refresh when you've got Zoom It on it, so don't put Zoom It on it when you're recording. Pro tip. Where's the drum roll? Look at that. Look at that. So you can see how if size on disk and being able to run multiple instances of those containers is important to you, as it is to me, this native AOT stuff is going to be very important to you, just because of the size on disk parts and being able to spin the app up quickly. I'll be showing you the repo here in just a moment. I'll show you the URL for it. It is not public. I'll make it public as soon as I get done. If I can go back to my slides, please. If I can go back to, thank you. Let's give that person a round of applause. Thank you so much. Thank you. Cool. And I know it's only day one, but I've been here for 3 days. Let's give the whole crew a round of applause. Oh my. This place looks like a Motley Crue concert. It's so beautiful. So essentially, we've worked really, really hard. Where's the calls to action slide? Okay, we worked really hard. Okay, and it doesn't come for free. You have to do some work too. So we have expectations from you. We want you to go out, and if you're not already partying with .NET 7, do so. If you're not partying with .NET at all, just go ahead and start partying with .NET 8 Preview. We're in preview 4 or 5-ish right now. It's very, very, very important to us that you try out .NET Preview and you tell us what you think. Try to upgrade an app to .NET 8 Preview. Try it out. Come to GitHub and tell us how the experience was. Find us on social media. Look at our YouTube. Please try .NET 8 Preview out and give us your feedback. We really, really care about making sure that cloud-native developers have everything they need, at least for this round. But we have big plans for the future that we'll talk about next year. So, but we do want you to try it out and tell us what you think. Last thing, I'll try to duck under the thing. Scan this because it will direct you to a lot of other awesome cloud-native sessions that are going on at Build this week. One of them is going to be happening shortly after this session. It's going to be Brendan Burns, Mandy Whaley, and Scott Hunter are going to be given a presentation on Azure and container development and stuff. I would highly recommend you check that one out. It's not going to go as deep as this does, of course, but it's going to show you kind of what's coming in the Azure world, which is pretty exciting. And I have a little bit of time left for questions, so Jeff, I can turn it over to you for questions, buddy. Do we have any? Or any in the room? Go ahead.
So from my observations, most impactful projects in cloud native ecosystem were built in Go. So moving forward, should we expect to see more projects built in .NET going through that maturity pipeline?
You said most of them were built in what?
Go.
Oh, in Go. Oh, the question was, he has seen many, many projects that are considered cloud native written in Go. Are you going to see more of these projects written in .NET? Yes, I'd say you are. Like YARP is a great example of a project that we put out to answer a lot of cloud native challenges. Orleans is another one. If you haven't taken a look at Orleans, it provides you a lot of capabilities to do microservice topologies in the back end, scale out, and machine-to-machine communication. But yeah, so hopefully that answers your question. Any others? One back here. The question is the resilience based on Poly, and will we have to use those? And these guys are nodding, yes. But we're working with them to make it even better. So, yeah. Great question, by the way, thank you. Anyone else? Any questions online? I don't see them. Go ahead. That's a great question. I believe your question was, she's used a variety of OTLP. You mentioned application insights. And you see that there's a little bit of a delay between like your application doing a thing and you seeing that show up in there. You saw with Jaeger and Zipkin, it was pretty quick. I mean, Azure's got a lot more nodes than my machine, so that might explain why. There is always going to be a little bit of latency potential for one of these things, especially if you're throwing a lot of telemetry out. You know, the more telemetry you're throwing out in the world, the more space you need, longer it's going to take, et cetera, et cetera. I can't answer that question explicitly in terms of, I can't tell you we're going to be faster than somebody else, but what I can tell you is it does take time to get that telemetry over, so that might be your delay. That might be the cause of your delay. Any other questions? Any online? Demo app. Ow! Demo app. I can do that. If I could go to my demos, please. I think I'm logged in. Thank you for reminding me. Repositories. Let me zoom in on it. Sorry, I'm going to make an ACA for you shortly. I just haven't had a chance to do it yet. It is right here. It's in my GitHub organization. It's literally .NET-cloud-native-build-2023. I'll zoom in a little bit more. Oh, it's private? Yeah, I'm going to make it public. I haven't made it public yet. I'll do it right now. I'll do it right now. Sorry. Now I'm going to have to 2FA. Okay, and I will also say, change visibility, change to public. Want to make it public? Yes, I get it. Make it public. Oh, God. My phone. My phone's over there. I'll do it, I promise. I'll do it. Thank y'all for coming. I don't have any questions up here. Thanks a lot for coming.